So we're going to continue with 3D coordinates. We're still going to be in section 1. The first thing I want to talk about is midpoint. How do we find a midpoint in 2 dimensions?
Add the two. Add the coordinate some first spot and then divide them by 2 and you add the coordinate to the second spot. You divide them by 2.
Good. What's another way to describe that? It's the average of each coordinate. So we still are going to do the average of each coordinate. Add the x's, divide by 2. Add the y's, divide by 2. Add the z's, divide by 2. I'm not sure why they call it D, but whatever. We'll go with it. Here are the 2 coordinates that we are going to find the midpoint between. So to find the midpoint, we will take an average of the x's, an average of the y's, and an average of the z's. Darby, what's our coordinate?
-1 and 0 for 2 times.
There it is. Can you handle finding midpoint? Okay. Now, why is it important for us to know how to find the midpoint? So we can do equations of spheres. You are exactly right. Okay? Any suspicions on what the equation of a sphere will look like? Oh, but with some z's that have been squared. That is exactly right. Everything is still going to be squared, even the radius. All we're doing is literally adding z minus j squared. Now, some of you are bothered by the order of the center. I am sorry. But the j is last.
Because I is in the
Because I is the imaginary number. We also use it for vectors. We do use j for vectors. Okay, so the center of a circle is HK. The center for a sphere is HKJ. We don't want to disrupt the Y being with the K. So your center, I mean, up there it looks funny, but when we do an actual problem, it won't. So if we have a sphere with center 2, -4, 3, and radius 3, I would not write all that down. What I would write is center equals 2, -4, 3, and radius equals 3. If we wanted to write the equation of this sphere, x minus h squared plus y minus k squared plus z minus j squared equals radius squared, which we can just write as So we'll come back to this. Okay, so before we talked about the equation of a sphere, we talked about the midpoint formula. And someone said that the midpoint formula could be helpful with the equation of a sphere. In what situation would the midpoint be useful? Darby?
If you have 2 points on the edge and you want to find the center.
Okay, if they give us 2 endpoints of, let's say, a diameter, the midpoint could give us the center, which would give us, the HKJ. All right? If we were to hypothetically have a problem like that, you use the midpoint to find the center. How would you find the radius?
The distance between the center and the diameter.
Okay, so the distance from the center to the end point would give you the radius, and we know how to do that using the distance formula. Okay, you could also find the length of the diameter with the distance formula and cut it in half. Okay, why am I talking about this hypothetical problem? Because your problem is one. Okay. The other types of problems you are going to see are ones like this. I'll give you a moment to copy this down. Okay, we just came off of our conics chapter. This should be like walk in the park here. If we are going to identify the center and radius of this sphere, we're going to have to complete the square so we can identify the x minus h, the y minus k, etc. So the first thing I'm going to suggest you do is reorganize it to group the x's together, the y's together, etc. Now, what do you notice about the coefficient of x squared, y squared, and z squared? They're all 1. That's helpful, isn't it? So x squared minus 2x plus a mystery number plus y squared plus 4y plus a mystery number plus z squared minus 6z plus a mystery number. I'm going to go ahead and subtract the 8 over and then balance the equation by adding those 3 mystery numbers. So, Amarissa, what completes the square for the x's? 1. Sydney, what completes the square for the y's? 2. No. 4. 2 squared, right? That's right. Good? And then what completes the square for the z's, Will? Okay. So our sphere is the equation x minus 1, the quantity squared, plus y plus 2, the quantity squared, plus z minus 3, the quantity squared, equals 6. You don't have to divide it over. No worries. Molly, what is the center of this sphere?
1, -2, 3.
1, -2, 3. And the radius would be what, Ryan? How do we identify the radius? Okay, let me rephrase this question. This 6 over here, what's in its place in that general equation? So like the standard form that I wrote for the equation of a sphere?
Oh, r squared.
Okay, so if that's r squared, what would the radius be?
12. I mean, that's 36.
If this is r squared.
Oh,
There you go. You're just going backwards, right? Okay, so our radius would be radical 6, so that when we square it, we get this number right here. What?
Would they usually turn out this nice? No. And then they'll use it.
Will they always turn out this nice?
Yeah.
Maybe, I don't know. Okay, now I do want to show you, don't write any of this down. Some of you are asking about conics in 3 dimensions, and I want to show you what they are. A sphere is obviously a 3-dimensional circle. This is an ellipsoid. Okay, every trace, if you were to cut this any which way, it would be ellipses all the way around. Okay? Ellipse in the XY trace, an ellipse in the XZ trace, an ellipse in the YZ trace. Okay? What does that look like? A blip? A rugby ball? Okay? That is an ellipsoid. Okay? This is an elliptic paraboloid. So it's a 3-dimensional parabola where the traces are ellipses versus a hyperbolic paraboloid.
Inverted triangle.
That's a three-way
Yeah.
triangle. Okay, so this is a 3-dimensional parabola where one of the traces is a hyperbola. So a hyperbolic paraboloid and an elliptic paraboloid. And then we have hyperboloids. Okay, 3-dimensional hyperbola. So this is a hyperboloid where it's all one piece, but then you could have like 2 pieces of a hyperboloid. Okay, so it's a 3-dimensional hyperbola where the traces, where one trace is an ellipse. All right. Homework time, yes.
With the hyperboloid ones, how do you know like which one would go separated with the big like together?
It depends on what these numbers are.
It says, like, one of them is 1 and the other is -1.
Okay.
Oh, there you go, there you go. Right there. And then, like, depending on where the negative is would depend on like where it opens. Pretty sweet, right? So any of you that get into calculus 3, you'll be working in 3 dimensions.